All right, and welcome back. Okay, first off, apologize for the quality of this video. My drawing software, for some reason, just wasn't really responding all that well with these graphs that I wanted already brought up. So I'm going a little bit different direction here. Okay, but what we're covering today is what we call periodic functions. Periodic functions. Okay. You might be asking yourself, well, what are periodic functions? Well, periodic functions are simply functions that repeat itself. It repeats its values in regular intervals. It's repeating its own values over and over and over again in regular intervals, okay? And the best way to determine if a function is periodic or not is to look at its graph. And what I have here is a nice little graph. We can see it's kind of waves, right, going up and down in regular intervals, and that's what a periodic function is. So this is the graph of a periodic function, okay? Now, because it's a periodic function, we can classify it based off a few characteristics. We can kind of determine some key characteristics of this graph, okay? The first of which is what we call the period of the function. Okay, let me go ahead and do a different color here. The period of the function. Now, the period of the function is the horizontal length of one full repetition, and we call that full repetition a cycle. Okay, so it's one full repetition. It's a horizontal length of one full cycle. Okay, and because these graphs kind of continue and do the same pattern over and over and over again, the best way to kind of determine what the period is to kind of just pick a point and trace the graph throughout one of its cycles. So for example here, let's say I just want to start right at its y-intercept and go to the right. Well, this graph goes up to its maximum, comes down to its minimum, and then comes back up, and that would be the length. That would be one full cycle. That could be one example of a full cycle. I can do other ones if I wanted to. If I wanted to, I could have said, hey, let's say I start here at this maximum, and I go down, and I go down to its minimum, and then I go back up to its maximum. You could have called that one full cycle, okay? And regardless of which one you pick, they're actually going to have the exact same horizontal length. If we measure the distance here between these two maximums, that distance from negative 3 pi over 2 to positive pi over 2 is 2 pi. And I could have done the same thing with our other cycle. Okay, if I measure the distance from this point here, travel along its cycle, notice a distance between these 2 points within the full cycle, 0 to 2 pi, is also a distance of 2 pi. I could have also done from the minimum to minimum. This total distance here is 2 pi. So the period of this particular function is 2 pi. Okay, so that is one key characteristic. Another key characteristic is what we call the midline. Okay, what we call the midline. And it's just a line that kind of splits this graph perfectly in half, okay? And it's generally going to be a nice horizontal graph, okay? It's what splits this graph perfectly in two. Well, it might be a little difficult to see, but it's actually going to be kind of this line right here. This one might be a little difficult to see. If you notice, if I kind of drew this line right here, along here, this actually kind of splits these parts directly in half, okay? And that's what we call the midline, okay? And in this particular case, y would be equal to 1.25. Now, another way of actually figuring out what the midline is, if it's a little difficult to tell, is you can actually average the max and min. Average, max, and min. So if I look here, the maximum is 2, and the minimum is about 0.5, right? It's about 0.5. If I take the average of these two, I get 1.25. So that would be the equation of the midline. That's actually a nice little trick you can use to determine what the midline is. Okay, so the midline is a graph that splits up the graph, or the midline is the line that splits the graph up perfectly in half. Okay, and that actually leads us to the next part, which is the amplitude. The amplitude. Okay, now amplitude is half the total distance from max to min. Half the total distance from max to min. So if I measure this out, the distance from the maximum to the minimum, so the minimum is right over here, so I'm just going to kind of horizontally draw it out. This total distance here is 1.5. Okay? Now the amplitude is half of that total distance, which is 0.75, which is also the distance from the midline to the maximum and from the midline to the minimum. That's another way you can determine if you got the midline correctly, okay? The midline splits it perfectly in half because the amplitude, which is half that total distance, is also you can kind of think about it as a distance you go up from the midline to hit the maximum and down from the midline to hit its minimum. Okay, so I want to take a look at another graph. So take a look at this one. So this one we could definitely see a pattern emerging as well. Okay, so we can find all of those pieces. So we can find the period. Remember, the period is the horizontal length of one cycle. Okay, so we can kind of start anywhere. We can start at a max or a min if we want. We can start at like one of these relative max and mins. It doesn't necessarily matter. I'm going to start right here, and I would go up, down. This would be one cycle. I'm still going. There's my next point. Notice I traveled up to the maximum, down to the relative min, up to the relative max, down to the absolute min, back up to where I started. And that horizontal length here is pi. From 0 to pi is a distance of pi. Okay, so that would be the length of the period. Okay, now the midline. Let's take a look at what the midline would be. Well, the midline in this one might be a little bit easier to notice. The line that splits it up perfectly is actually the x-axis. If you notice, it splits this up literally perfectly where these two distances are equidistant. Okay, so the midline is y equals 0. Okay, so there is our midline. The last thing we can find is the amplitude, and it doesn't necessarily matter what order you find these, okay? It doesn't matter what order you find these. The amplitude, remember, is half the total distance from max to min, or you can think about it as the distance from the midline to its max and min. And if I look right here, it's about 1.75 up from the midline and about 1.75 down from the midline, which means the amplitude is 1.75. Another way of thinking about it is that the total distance from max to min is right around 3.5, and half of 3.5 is 1.75. Okay, so that's periodic functions. What I want you guys to do, if you think you can handle it, I want you to pause the video here and try to find those 3 characteristics of this particular function. Go ahead and pause the video and do that. Okay, so hopefully you went ahead and tried to find the 3 characteristics. I'm going to go ahead and write them down here. So I'm going to go ahead and find the period first. Now remember, you can measure this a few different ways, max to max, which would actually be a little bit more difficult in this case, because if we notice, you kind of hit that max twice in a row. So it might be easier to kind of trace out one full cycle. So that's what I'm going to do. I'm just going to start here, and I go up to a relative max, down, back up, back down, back up, back down, back up, or back down, back up, back down. And notice that's where I stop. I can also kind of see right to the left of where I started, I was down right around here, and I kind of go back along. I notice right here it kind of hits that point as well, but we never actually hit these maximums, so we had to kind of continue tracing it along, which means this is one full cycle, and the length of that full cycle from 0 to 2 pi is 2 pi. Okay, so that would be the period. Okay, from there we can go ahead and find, let's find the amplitude. Let's find the amplitude. Amplitude, remember, is half the total distance from max to min. Well, as we see here, this graph has an absolute maximum of 4 and an absolute minimum of -2. So that total distance from 4 to -2 is 6, and half of that is 3. So the amplitude you should have gotten is 3, which means the midline. Midline should split it right in half. Okay, should split it right in half. So basically I need a line that I go 3 above it, I hit my maximum, 3 below, I hit my minimum, and that's actually y equals 1. If I go up 3 from 1, I'm at my maximum. That's my amplitude, right? My amplitude is 3. I'm going up 3 to hit my maximum, and I'm going down 3 to hit my minimum. So the midline would be y equals 1. All right, so that is periodic functions. Hopefully the video didn't throw you off, since it's a little bit different than my other ones. All right, next couple videos we're going to be starting to graph trig functions, sine, cosine, tangent, okay, which actually happen to be periodic functions as well, which turn out to be some pretty cool graphs. Okay, but until next time, I'll see you later.